Thank you, everybody. This is Client-Side Chaos, and I'm Jayton Birch. That's the name at the bottom. And yeah, thanks for coming to this talk. And if you're coming to this talk, you probably maybe have some concerns with the front end. You may have heard some scary stories about the front end. And we just came out of John Hammond's talk, and he talked a lot about how there's so much to know. And in the front end world, there's a whole lot to know. It's too much, and a lot of it is unnecessary. So I'm going to try and talk about some of the things at a high level for you security professionals on what you can look out for. So when your front end devs start huddling and whispering things about server-side rendering and React server components, you can understand it enough to know how to secure your enterprise without having to know all the details, because you don't want to know the details. It's not what this is about. All right. So the front end, right? Okay, we got some buttons and colors and images, and what's the big deal, right? Browsers have been around for like 20, 30 years. We should have this all figured out. Everything should be patched. Obviously, that's not the case. This is what you know and love. This is the OWASP Top 10. We know all about this stuff. This is from 2021. It's the latest one. They're coming out with a new one like next week. I'm just a week shy. But the thing I want to point out is that a lot of these vulnerabilities are exclusive to the front end or are heavily related to the front end, and they're always at the top. They will not go away. And it's hard to categorize some of these things, but I'm going to focus on injections. But yeah, so with all these fancy new front end technologies, these front end vulnerabilities just, they don't go away. And so kind of a big takeaway I want you to get from this talk is that there's a myth that I always hear when we discuss security and software, and when we discuss it at work, is that front-end validation or sanitization is a nice to have, right? And so you want your web server to do all that good sanitization before it goes to the database. And it'd be nice if the front end did it, but it's not really that big a deal, right? You may have heard that. And we love front-end validation. Have you ever filled out like a government website and you missed a field, so you submit it and it comes back with an error and everything's gone? Yeah, that sucks. But so there's some good user quality experience. And so I want to kind of talk about that commonly held misconception about we don't need to worry about the front end too much. So I'm going to kind of do a demo of how you know how this kind of works. So I have our network. Here's our database. Here's our web server that handles REST API requests, and then something on the edge of our network, like a WAF or something to inspect the contents of our requests. And then, of course, we have our hacker who has JavaScript loaded up from our website that we provided to this hacker, and you know how it goes. I don't have to explain it. So some sort of injection goes into a request, and whether it's a form or whatever, and we fill it out. So the common way of thinking that I kind of want to challenge is that we've kind of considered this kind of like a conveyor belt. So we got a bad payload, and somebody's got to catch it, right? So the JavaScript in the browser shouldn't let that get sent, but it might. It might get sent. Oh, it might make it through the WAF. It might make it through your web server that handles the request, and it might make it all the way to the database, right? And if we have a reflected injection like cross-site scripting, which is still very common, it has to go all the way to the database, right? But it has to come all the way back out to our innocent victim here. And if the JavaScript allows this payload to be interpreted as JavaScript, it will also be a big problem. And so to kind of challenge that, instead of yapping, I'm just going to go right into a demo to kind of demonstrate what I want to talk about here. So I'm going to pull up this this nice little web app that I made. I think you could see that there. Okay, it's a website to save memories. We could pretend that we could share them with somebody else. We got an image, we got a link, and so I'm not demoing cross-site scripting to teach you about it. I'm trying to make a bigger point, but we all know what it looks like. So let's try and make a little hack, right? So we're going to create a new memory, This is an image of cheese that I found online. And then look, it already saves my payload. It knows what I want. This URL will go into the href attribute of the anchor tag, and then create this here. Very nice. Here's our memory. Let's test it out. If I click this link, instead of going to a link, it stays on the page with all of the document and session IDs and cookies, everything I need with JavaScript that I could execute. Isn't that great? Okay. So click save. It goes to the database and it persists and it comes back to me, and I could, maybe this app lets you share it or something. I could send it to a victim. So I'm going to do something to validate, sanitize this. And what I'm going to do, I don't know if you could see, I'm just going to delete the URL from the incoming request body to never save it. That's a good way to keep it safe, is just delete it so that it never happens. Okay, so now I'm going to do this again, and I want you to look out for if there's any way, any catastrophe, any sort of big, scary hack can happen. Let's try it again. So, all right, I'll do another test. I'll use the same image of cheese because I want to remember it. I'll do same payload. I'll just say test, preview. Here we are. This is what I want to see. Okay, excellent. Now, let me open up the dev tool so we can even look at the request. It gets made here. So I click save, that request gets made. And there is no URL, so we're safe. Did any eagle-eyed hackers see any way that could possibly still be exploited without the back end coming into play? Anybody? That's all right. Let's run it back. So when I went to go make this exploit here, this payload that I send to people, before it gets sent to the database, I have it here as a preview. And when things are held in any sort of state in browser technologies, there's a whole plethora of places it could be indexed to DB, session storage, or just held in memory of the JavaScript runtime. But here, I'm using an extremely common pattern that I see in almost all of the third-party software I use for work, at least, is I'm saving the state of this form in the URL params up here at the top. So my payload exists. Oh yeah, you can't see that. Yeah, my payload exists in the URL, and a bunch of apps that you use do this. And so if I open an incognito, I could just send that. I could just send this to somebody. So regardless of what the backend is doing, this could still be exploited. And so, and this is a very common exploit. If you go to like HackerOne or bug bounty programs and look and filter for cross-site scripting reflected with URI or URL in the keywords, you'll see hundreds of occurrences of these in just the last few years, and those are only the disclosed ones. But I'm not. My point is, I'm not teaching you about this specific exploit. My point is that the front-end validation and sanitization and hardening is independent of the back-end. So this exploit could still happen not because of the back-end, but in spite of it, in spite of all the secure things that it does. All right, that making sense? Okay, so going back to our little diagram here, you could just send payloads directly to the victim, and it doesn't matter what your WAF or your web service is doing. And so my whole overarching point is that this isn't a conveyor belt where you just hope, okay, I just hope somebody along the line catches this, but rather these are two separate attack surfaces. And so what that might look like for your enterprise is if you do something like production readiness or like a security checklist of some kind, you need to have one for your front end and check for cross-site scripting, all sorts of those vulnerabilities, as well as the back end separately. All right? Fair enough? Okay. And regarding that front-end attack surface, It's getting bigger and bloated and more complicated, and trends come and go, fashions come and go, and it's getting scary. So server-side rendering is what I'll talk about. That's a big one that introduces new infrastructure sometimes just to render your UI. Chrome extensions, I'm not even going to talk about it, but there's some great talks from DEF CON this year about Chrome extensions using clickjacking and things like that. New ways to store data like IndexedDB, where data is stored outside of your infrastructure for the user. And I threw up the Comet browser because this year now browsers get their own AI agents that execute actions on behalf of the user. And we don't even know what that really looks like yet. And so of all those things, I wanted to pick on React Server Components. So any enterprises, companies using React here that you know of? Yeah? So according to survey data and download data, this is by and large the most common way to make new front-end applications. React, I'm talking about. React came out with a new spec where they are doing React Server Components, where you do some stuff on the server and some stuff in the client. And it's created a whole new paradigm shift. And you're going to hear these words at work. And I just want to arm you with some knowledge about it so you don't have to care about all the details, but you can understand it at a higher level. So I talked about React Server Components at a Utah JS conference. And the way I'm going to describe it would have made them really mad, but it's kind of like PHP. You remember PHP? There's some good times with PHP where it's rendered on the server, and so it gets all the data and all the things you need, and then it just sends it to the browser, and then the browser just has that as rendered HTML. When React first came out, the big thing was SPA, single-page applications, if you've heard of that, where they basically send just JavaScript. The JavaScript does all the work. And if it needs data from your enterprise, it'll make a bunch of REST API requests. So it gets sent code, and then the stuff is rendered on the client. And if it needs data, it does fetching. So React Server Components kind of does both. We have some stuff rendered already, some stuff rendered on the client. And so you may already be kind of smelling what security things could pertain to that. So to establish what the paradigm shift is, I want to talk about how it's been before. We have a server and a client, and we have a boundary between them. And we've historically been very deliberate about when we cross that boundary, right? So we have our technologies, the good old stuff. So if you want to then cross the boundary, you go to your org and you design an endpoint. You spec it, you name it, you get buy-off on it, and then you take it to committees, naming committees, security committees that you may be a part of to make sure it's scoped to the right thing and it has the right rights, all that good stuff. And then you very deliberately place your endpoint in across that boundary. But with React Server Components, which is the new default paradigm of React frameworks like Next.js, what happens now, you have your UI element, your component, and then at build time, your build server will determine if it goes on the server or on the client, which is a trade-off because it's excellent for not caring about stuff as a dev, you just want your stuff to be on the page. But it may introduce vulnerabilities if that said developer does not know what's going on under the hood. So I'm going to hop into a demo real quick of what that looks like. So I have this app here that uses React Server Components. I have two components boxes. You can see a client component and a server component. That server component was rendered on the server and sent to the browser. Client one is rendered on the client. And so if you see, just ignore all this. I'm not teaching React. You don't need to look at all that React stuff, but there is some stuff I want to show. On the client component here, I have a log. Let me zoom in a little bit. says this is a log from the client component. And if I go to my browser, you'll see that as well. This is a log from my client component, right? It's a thing that gets run on the client, so that gets executed on the client. In my server, because it's running in a safe, trusted environment, that's where we keep our secrets. That's where we keep our API keys, our session tokens, our session password or server passwords. And my secret here, I listen to K-pop Demon Hunters even without my kids. And that is safe, and it's on my server. No one will know because it's in a trusted environment. And so my point is, if we want to cross that boundary, if I wanted to get this out to a client, like my secret, I'd have to be very deliberate, or I have to be very stupid with how I configure things. But okay, let's say that our product manager or whatever tells us, okay, I want that server component. It would look really nice if it was in the client component, right? So let's do that. How many story points is that? I don't know. I'm gonna comment it out of the layout, and then in my client component, I'm going to render this. And then I'm going to build and run. I have to do a prod build because in dev, it'll show server logs in the client to help you, but it also makes it a little more confusing. Okay, wow, look at that. We can sell that off to our product manager. Oh, excellent. That's gonna boost revenue or whatever. But look, so now the client is logging my dark secret about my new love for K-pop. So now it's logging to the client. And so my point I want to get across is that I moved some UI around, and the build server decided that it's going to send stuff to the client. I did not specify that. I didn't put it in a folder that said, these are my client-side stuff. I didn't rename it to like a client-side name or anything like that. It did it on my behalf to give me some benefits in deving, but also, if I didn't know what was going on, I just exposed all my secrets. And to reiterate, so React Server Components is kind of the new default paradigm in these React frameworks, the bigger one being Next.js. And so you kind of have to, if you're using Next.js now and you're starting new, you kind of have to like opt out of this in a way. So yeah, be on the lookout for that word there, React Server Components. I'm going to demo one more thing regarding these React Server Components, because one cool element of it is you can import a function from the back end in your front end, and you can run that function. Sounds pretty cool, right? So if I have a UI element on the client, but I want to call something on the server, to the dev, it's really nice. You just import it into the file and you just run it. Really neat. But as we know, the web hasn't changed. So underneath the hood, there's still that endpoint that gets created. However, this endpoint was just created by the build server on your behalf. You didn't deliberately design it, name it, get buy off on it. It just happens. So there's that trade-off. It just makes the endpoint, right? Because I just want to move stuff around and do stuff. But from a security standpoint, that could be kind of a concern. And so if you're making a bunch of server functions and then calling them from the client, you're introducing all these new endpoints. These endpoints that used to be very, that were handled with a lot of care and deliberately made. And so to show how that works, again, you could ignore most of this code, and some of you may not be coders per se, but you can see this is my client-side file. I can import this function, log on server, and then call it in my client-side code. So when I click this log on server button, it logs to the server. How cool is that? So as you can see, the trade-off, that's some pretty cool deving. You could prototype very fast, but what is going on under the hood? So let's look at what calls are actually being made. Sorry, I zoomed in and now it's like too much. Okay, So for that, So for that request, all right, so zoomed in, hold on. You can see the request is being made just to the root. There's no name because we didn't make a name. It was just made by the build server. So the way that it determines what it calls next is via this next action. And so this is a hash generated off of the source code with a couple of other things. That's not super important, but there's some confusion on this because Next.js, the implementer of the React Server Component spec, says, careful, because all your React Server functions are public. But people look at this hash and go, well, mathematically, they're never going to guess this hash. So my endpoint is very secure. But it's funny to remind people that your client side needs to know that hash in order to make that call. And so it's just right there in the source code. So in my production minified files, I have that hash. And so you can just do a search for the create server reference and go get those hashes and poke and prod at these endpoints like the endpoints that we know and love and look for those OWASP vulnerabilities that have always been around, except these endpoints may have been made by mistake or were vibe coded or something of the like. So I'm out of time, but that was client-side chaos, and I hope I scared you a little bit, and I hope you can remember some of these words and technologies so that you can understand them at a high level to help your enterprises be more secure. And I'm just trying to get you to my LinkedIn QR code. That's all. But I'm doing all these animations. Oh yeah, I'll do a quick TLDR. Yeah, your front end is its own attack surface. So treat it as one and audit it as one. And so I've been Jayton. Thank you so much. Enjoy the rest of the conference, and I hope you have a good day. Thank you.